So this is Nirbhay and welcome back to the final video of subnetting. Okay, so in this video we're gonna discuss about what is VLSM and how it is useful by taking some real life examples. Okay, now on the screen you can see like I have taken a router. Okay, and there are three different interfaces like interface 1, interface 2 and interface 3, to which also we can denote it as subnet 1, subnet 2 or subnet 3, and on each interface I want to assign different IP ranges, so that on interface 1, let's say I want to attach 12 different host or server. Okay, and on interface 2 I want to assign 60 different host or server, and on interface 3 let's say I want to attach 30 different host or servers. Okay, and the given IP for us is 196.20.20.0. okay, which will be by default with /24 notation. So how I can divide this IP address and allocate different ranges on each subnet and ensuring that minimum IP addresses are getting wasted. Okay, so to understand this, let's understand what is VLSM and why it is useful. Okay, so first let's see what it says. Okay, so VLSM, which also known as Variable Length Subnet Mask, is a subnetting technique that allows you to divide an IP address space into subnet of different size. Okay, unlike fixed length subnetting where all subnets are of same size. Okay, so what exactly this means? Okay, it says unlike fixed length subnetting where all subnets are of same size. Okay, so I have taken the downside of the normal subnetting. Okay, so let's say suppose you have a class C network IP address, okay, that is 192.168.1.0/24. okay, so which by default has 256 addresses that can be used as host. Okay, now you want 4 subnet. Okay, and in first subnet you want 120 host, 50 host, and in third you want 20 and then 10. Okay, so in the previous, as we have seen, all the subnet will be of same size. Okay, so at that time we used to take the host that are max required. Okay, so what was the max host? So it was 120. Okay, so if we do subnetting, so at that time something IP would look like 192.168.1.0/25, I guess. So as the CIDR range for the max required host was /25. So in the old subnetting method we used to allocate /25 only for all subnets. Okay, but if you see, like, there are 256 hosts possible in class C. Okay, and if we calculate all these hosts like 120 plus 50 plus 20 plus 10, so it will total will be 200. Okay, so logically it is possible, like we can create 200 different hosts by using this class C IP address. Okay, but it will be same CIDR for all. Okay, so in first subnet you can see there is a requirement of 120 host only. Okay, but with /25 notation the usable hosts are around 126. Okay, so 126 minus 120, it will give us around 6 hosts that are getting wasted. So that's okay. But in second subnet you can see 50 hosts were only required. Okay, but as it is with /25, so here also possible host will be 126 only. So minus 50, so it will around 86 hosts that are getting wasted. So you can see there are a lot of hosts are getting wasted. Okay, if we sum of this also 126, like these are usable. Okay, but the total would be 128 and 128. Okay, so if we sum up this, so this both will only result with 256 hosts. Okay, so that is the total possible host in this class C. Okay, so we can see like logically we only require 200, but with old subnetting we are consuming those with 2 subnet only by wasting many hosts like 86 over here and 6 over here. Okay, so to overcome this we need to use VLSM. Okay, so let's continue with our description. Like VLSM is a subnetting technique that allows you to divide an IP address space into subnet of different sizes, unlike fixed length subnetting where all subnet are of same size that we have seen below. Okay, VLSM allow more efficient use of IP address by allocating IP ranges based on actual reach. Okay, so what it means, like instead of giving all with /25 notation, we can give some like first for /25, and let's say for 50 we can give like /26. So it will vary, and there will be minimum number of hosts that will get wasted. Okay, so let's see why it is useful. Okay, so as we have seen, efficient IP address utilization. It avoids wasting of IP address by tailoring subnet size to actual host requirement. Like we are changing it from /25 to /26 and like /28 /29. Okay, and second, it is better for network design. Third, ideal for hierarchical IP design. Helps in designing enterprise level networks where departments or branches need different sizes of subnet. Like you may have UAT, dev or prod that would need some different amount of host, like 120, 50 or anything. Okay, and VLSM, it supports CIDR. So now let's back to our main screen. So as we have seen, our requirement was we have taken, so as we have already seen, our requirement was we have taken one router and there were three different interfaces on which we have to give three different ranges, such that on first interface we want 12 different host or server, and on second we want 60 different host or server, on third subnet we want 30 different host or server, and the given IP was this only. So how we can allocate different ranges on different interfaces by ensuring that minimum of IP addresses are getting wasted. Okay, so in first step what you have to do, you have to write the given IP as it is. So what was the given IP? It is 196.20.20.0. okay, now as this IP belongs to class C. Okay, so in class C the first three octets are given to network, as you can see, which are represented by 1, and the last octet was given to host. Okay, so what we have to do, we have to write the bit that are given to network as it is and the bit that are given to host all in binary. Okay, so we will writing 196.20.20 as 3 were given to network. Okay, and the last was given to host. So the binary of 0 would be 8 times 0, 5, 6, 7 and 8. Okay, now so what will be its subnet mask? So what is subnet mask? So it represents the number of bit that is given to network or to host. Okay, so how many bits are given to network? So all ones in decimal, it represent with 255, 255.255.255.0. Okay. So this will be the by default subnet mask. Okay, by default. So now in second step, we have to first identify what was the maximum number of hosts that was required. Okay, so we can see the 60 was the maximum number of hosts that was required. Okay, so we have to use the formula, that is 2 raised to n minus 2, and we have to satisfy this condition, that is it should be greater than or equal to 60. Okay, so we have to put the value in n such that it should be greater than or equal to 60. Okay, so from where we have to take, again from this table. So if you are getting confused here, so I would highly recommend you to watch my previous video. If we take n value as 5, like 2 raised to 5, so it will give us value as 32, so which is less than 60. Okay, so that would not work. Okay, so we have to take 2 raised to 6, so it will give us value as 64. Okay, so 2 raised to 6 minus 2, it will be 64 minus 2, it will be 62, that is greater than or equal to 60. So n is equals to 6, it satisfies our condition. Now in the third step, what we have to do, we have to write this IP again. Okay, so 196.20.20.8 times 0, 8. Okay, now as our n value was 6, okay, so we have to give 6 bits to host. Okay, so from right to left we have to give 6 bits to host, means till here it will be for host, and for rest we have to give it to network. Okay, so 196.20.20, 2 bits for network and 6 bits for host. Okay, so now we have to write it in decimal, so it will be 196.20.20. okay, now the value of this 7th and 6th bit, it will be 2 raised to 7 and 2 raised to 6, will be 128 plus 64, which will give us 192. Okay, and subnet mask will be 255.255.255. Here in fourth octet we have given some bit to network. Okay, so in decimal it represent as 192. So this will be the subnet mask. So now what will be our first subnet ID? So if you have watched my previous video, you know, like we can write the given IP as it is, like 196.20.20.0, or you also know the logical reason, like we do AND operation between this given IP and this subnet mask, that I am not gonna do here. Okay, so basically you can write the given IP as it is. Okay, so now how many extra bits we have given to network? So it is 2 extra bit we have given to network. Okay, and by default CIDR range was with /24. Okay, so now as we have given 2 extra bits, so it will become 26. So this will be our first subnet ID. Okay, so now the question is, what will be our broadcast IP, means last IP for this subnet? Okay, so our n value was 6. Okay, and in this table 2 raised to 6 it represent with 64. Okay, so 64 was total possible host. Okay, total host. And so after subtracting these two, which first is for subnet ID and the last is for broadcast IP. Okay, the number of usable host was 62. So this was usable host. Okay, so as the total possible host was 64. Okay, so including this 0, the 64th IP would be 196.20.20.63 and /26. Okay, so usable host range will be, like usable host range will be, it will go from 196.20.20.1/26 till where it will go? It will go till 62/26. Okay, so this would be our usable host range. So we have found the subnet ID and the usable host range and broadcast IP for this interface where 60 host was required. Okay, so now we will find the subnet ID for the other interface, that is interface 3. Okay, where host requirement was 30. So we will find the second subnet. So how we can find the subnet ID? I will provide you the two methods. Okay, so in first method we have to see this binary number and we have to identify the value of first bit that is given from host to network. Okay, so what was the value of the first bit that was given from host to network? Okay, so it was at 6th position. Okay, so its value would be 64. Okay, so our next subnet, means second subnet, would be 196.20.20.64. Okay, so if we see our second method also, so you can see like broadcast IP for the first subnet IP was ending with .63. So it will be the last IP for that range. Okay, so the next IP will be the subnet IP for the next range only. So by this way also it will be .64 only. Okay, so now how many hosts we want? We want 30 hosts. So in the next step, what we can do, we can write the bit that are given to network as it is and the bit that are given to host in binary. So it will be 196.20.20.8 times 0. Okay, so now here what was the number of hosts that was required? So it was 30. So we have to satisfy this condition, that is 2 raised to n minus 2, which should be greater than or equal to 30. Okay, so if we take this 2 raised to 5, okay, so it will give us 32. Okay, means 2 raised to 5 minus 2, which will be 32 minus 2, it will give us 30, which satisfy the condition that is greater than or equal to 30. So our n value becomes 5. Okay, so as we have seen, the value was 32. Okay, so the total host range was 32 and usable was 32 minus 2. So 30 was usable range. Okay, so as our n value was 5, so we have to give the 5 bits to host and rest we can give to network. Okay, so we can simply write it as 196.20.20.3 bits given to network and 5 bits given to host. Okay, okay, so now what will be its CIDR range? Okay, so as we can see, 3 bits we have given to network. Okay, so by default the CIDR range for class C is /24. Okay, so we are giving 3 bits more to network. So 24 plus 3, it will be 27. So CIDR range will be /27. Okay, so now what will be our broadcast type? So it will be 32 next bit including this 64. So we can either manually calculate, or if the number are too much long, so what we can do, we can find the next subnet ID. So what will be our next subnet ID? It will be basically the value of the first bit that is given from host to network. Okay, so this was this value, like this bit. Okay, so it is as 2 raised to 7, 2 raised to 6, 2 raised to 5th position. Okay, so which value was 2 raised to 5, which give us 32. Okay, so if we add 32 more over there by including the 64, so it will give us 196.20.20.95/27. So it will be our broadcast IP. So what will be our usable host range? So it will somewhere start from .65 and it will go till .94. So this would be our usable host range. Okay, now what will be its subnet mask? So as it represents the bits that are given to network and the bits that are given to host. Okay, so here in class C the first 3 octets are given to network always. Okay, but in the 4th octets some subnetting is been done. Okay, so if we sum up these values like 128 plus 64 plus 32, so it will give us 224. So we have to write this here, 224. It will be its subnet mask. Okay, so now we have find the subnet ID, the usable host range, the broadcast IP and the subnet mask for this interface 3. So now in the step 6 we have to find the third subnet ID that can be given to this interface where host requirement was 12. Okay, so what will be our third subnet ID? So now we know the third subnet value will be the IP after this .95. Okay, so it will be 196.20.20.96. How many hosts we want? We want 12. So now we will write the bit that are given to network as it is and the bit that are given to host all as 0. Okay, so we will write 196.20.20.8 times. So now the requirement was for 12 hosts. So we have to use again this formula, that is 2 raised to n minus 2, which should be greater than or equal to 12. Okay, so if we take value of n as 4, okay, means 2 raised to 4 minus 2, which will give us 16 minus 2, which is 14. Okay, so it satisfies the condition, that is it is greater than or equal to 12. So our n is now 4. Okay, so as we know 16 would be total host. Okay, and after separating these two, 14 will be usable host. Okay, so we have find both these things. Okay, so now as our n value was 4, so we have to give the 4 bit to host and 4 bit to network. So we can write it as 196.20.20. as 4 bits are given to network dot 00 4 times 0. Okay, so as we have given extra 4 bits to network. Okay, so 24 plus 4, it will give us /28. Okay, now we have to find its broadcast IP. Broadcast. Okay, so it is basically in the last IP of that range. Okay, so as there were total 16 hosts possible. Okay, so from 96, including this 96, if we calculate the 16 total hosts, okay, so it will go till 196.20.20.111/28. Okay, so it will be our broadcast IP. Now what will be our usable host range? So it will be the IP between this 96 and this 111. So it will somewhere start from, you can say, .95 till it will go till 110/28. Okay, so this will be the usable host. Okay, so now what will be our subnet mask for this? Okay, so as we have given 4 bits extra to network. Okay, so if we sum up their value, so it will be 128 plus 64 plus 32 plus 16. Okay, which will give us 240. Okay, so we can write its subnet mask as 255.255.255, and as in 4th octet subnetting is being done. Okay, so its decimal value was 240. So this will be its subnet mask. So now we can give this first subnet ID on interface 2. okay, or subnet 2 we can say, and similarly the second subnet ID on interface 3 or subnet 3, and similarly the third subnet ID we can give it on interface 1 or subnet 1. Okay, so by using this IP range we created 3 different subnet and we make sure that minimum number of hosts were only wasted. So that shows the whole power of VLSM. So if you find this video helpful, please like, subscribe and share. And if you have any doubts or any suggestion that I could have improved in this video, and if you want me to make a video on any topic, then please comment in a comment section. Till now, bye.